give you a basic idea of what an acceleration is. Okay, so acceleration, when I say acceleration is basically written as acceleration. I can say it is v minus u by t. So when I say it is v minus u by t, what I mean to say is v here is the v here is the final velocity. V will be the final velocity. U is the initial velocity. Okay, and t, you know, it is the time interval. Okay, now see, suppose you consider that this is a car. Okay, suppose this is a car. Say it is moving in this direction with a velocity u. Now say this is the position 1. Now when it reaches the position 2, the car reaches this position, and the car at this point of time, okay, so at this point of time it applies the accelerator. Okay, so when it applies the accelerator, definitely this speed, I mean this u will increase. Okay, if this was say 10, now when it applies the accelerator, it say becomes say 11, say 12, whatever, I don't know. So now when it reaches at this point, say position 3, okay, I'll draw the car again. Say this is the car again. When it reaches the position 3, so this is the third position. Now here its velocity becomes v, which is the final velocity that I was talking. So this here is the initial velocity that I was talking. This is the final velocity that I was talking. So now from here to here, say it has taken t amount of time. Say t seconds is what it has taken. Now if it has taken about t seconds, what I can do is I can say that the acceleration will be a rate of change of velocity. So what is the rate of change of velocity? Rate means something divided by time, and the change in velocity will be v minus u. And that is, now let's see what will be its unit. So the unit of velocity would be what? This will be meter per second. Minus meter per second will give me meter per second only. So this is meter per second, and time is divided by second. So this one goes up. So ultimately what I get is meter per second square. So hope this part is clear. The unit of acceleration is this is the unit of acceleration, which is meter per second square. So hope this part is clear. I'll pull it up a bit so that you can see. Okay, so now if this is the unit of acceleration, now so this was the mathematical part. I'll show you. This is the mathematical part, and this is the unit. Now make sure one thing, that acceleration, when I say acceleration, it is a vector quantity. Now why it's a vector quantity? Now see here, vector quantity, I say acceleration is a, say I say it is a vector quantity because it has got both magnitude and direction. See, when you are calculating the acceleration from this formula, definitely you will get a value. Okay, and you come here, you see that there is a direction that the car is following from position 1 to position 2 to position 3. So what I can say is it has got both magnitude and direction. That's why it's a vector quantity, and it makes some sense really, because to see the other way around, velocity, this one, change in velocity, so this is a vector quantity that you know, and if you are dividing that by time, So this thing should be a vector quantity. That is clear. But then why? How it is coming? That you can have a clear idea from here that the car is moving from position 1 to position 2 to position 3, and then while it is moving in this direction, say towards the right, okay, say towards this direction it is moving, and it has got a value. So if you substitute this v with some, say the initial velocity was say the final velocity becomes 10, say the initial velocity was 5, and this thing happened for 2 seconds. So you can calculate really what is the velocity, what is the acceleration. So this is 5 by 2, which is 2.5 meter per second square. 2.5 meter per second square. So 2.5 meter per second square will be the acceleration, and that's how you can say that acceleration is a vector quantity, and at the same time because it has got both magnitude and direction. See you in the next video.